The goal of today's lesson is to solve a system of equations using what we are going to call elimination. Elimination is one of the two ways to solve a system of equations algebraically, which means using equations, so not using your calculator or a graph. So algebraically means you actually need to solve some sort of equations. The first one we've talked about is substitution. And the second one that we will be talking about today is elimination. We've already discussed substitution earlier this week, so elimination will look a little bit different. One thing to remember for today's lesson is that a coefficient is the value in front of a variable in an equation or an expression. So for example, 4 is the coefficient of x because that's the value in front of x, and -5 is the value in front of y. Make sure that you keep that sign in front attached to the coefficient so that you know whether that value is positive or negative. You know that when you add two equations together and you combine your like terms, you will also result in a true statement. This becomes extremely helpful when we're solving systems of equations using elimination. So I'm just going to look at one with just numbers, for example. Typically, we would take 3 and we would add 8 and get 11, and we would take 9 and subtract 6 to get 3. Both of those are true statements. However, if I looked at this system of equations vertically, I'm going to add them using columns. So 3 plus 9 is 12. 8 minus 6, or 8 plus -6, is 2. And 11 plus 3 is 14. If we look, now our equation is just one equation combined from two different equations. And we get that 12 plus 2 is 14, which in fact is still a true statement because 14 is equal to 14. Now I'm going to look at an example where we have one variable in our equation. And I'm going to, again, look at them as columns. So x plus 2x is 3x. When I'm adding those things together, I have 4 now plus nothing, which is just 4. And here I have 10 plus 12, which is 22. So now instead of solving two separate equations to figure out what x is, I've combined those two situations into one equation, and now I can solve for x by eliminating my coefficient and my constant. So I'm going to eliminate my constant first. Subtracting 4. Here, 22 minus 4 is 18. 3x equals 18. I'm going to eliminate my coefficient by dividing by 3. And here I get that the value of x is 6. So I can actually solve both of these equations for the value of x by combining them using addition. Now, it's not really helpful to do this with numbers or with one variable equations. However, with the next set of system of equations where we have x and y, it becomes extremely helpful. Earlier in this unit, we talked about how you need two equations to solve for two variables. So I'm going to actually take the exact same method and I'm going to add my two equations together. And I'm going to use columns to do that. Notice how like terms are in the same column. That has to be true in order for you to use this technique. Y plus 5y is 6y. 4x minus 4x, or plus -4x, is just 0, or it cancels out. And here we have 10 plus 14, which is 24. So now I have the equation that says 6y equals 24. And now I can solve for the value of y using normal solving techniques. If I wanted to solve this system, I could then continue and plug y into one of these equations to solve for x. So I'm going to do that and show you the full solving of a system in the next example. Now let's look at this system of equations. 2x plus 5y equals 17 and 6x minus 5y equals -9. Using addition, I'm going to combine these two equations together and add them by columns, just like we practiced above. So now I'm going to get 2x plus 6x equals 8x. And 5y minus 5y or plus negative 5y is going to cancel out. With elimination, you always want one of your variables to drop out. And that will happen when your coefficients end up having the same number but with opposite signs. So that's what we're always looking for with elimination. So 17 minus 9 is going to give me, or 17 plus negative 9 is going to give me 8. Now if I solve this equation for x, I'm going to get the x value of 1. But remember, a solution to a system of equations has an x value and a y value. So I'm going to keep going, and I'm just going to pick one of the two equations we started with. So I'm going to pick 2x plus 5y equals 17. And I'm going to use the x value of 1 to figure out the y value. So 2 times 1 plus 5y equals 17. 2 plus 5y equals 17. I'm going to eliminate my constant. And last step, I'm going to divide by 5 to eliminate my coefficient. And I get that, whoops, not x, we're solving for y. I get that y is equal to 3. So my final step is to make sure that I write my answer as a solution. So solutions look like points on a graph. So 1, 3 is my solution to this system. The big idea here is you need to look for a system of equations that has opposite coefficients in front of the same variable in order to use this technique. When you're using the elimination technique, you have to add the equations together. So you also need to make sure that you group or line up your like terms. And what we're looking for opposite coefficients would be something like negative 5x and positive 5x, because when you add those two things together, they will cancel out. Use these notes to complete the rest of your classwork. You may check in with the key once you are finished. Remember, today's goal for the lesson was to see how you could solve a system of equations using elimination. We had previously talked about substitution, and now we talked about elimination. Remember, what you're looking for with elimination is something that has a 5x and negative 5x, or having opposite coefficients in order for one of the variables to eliminate.